In this video, we are going to see what are cosets. Consider a group G and a subgroup H of group G. Take an element A from G and operate A with all elements of capital H. The set formed by these elements is called cosets. Since group G is not abelian always, I can have two types of coset. One is left coset and the other one is right coset. If I operate A from the left side to all elements of H, I get left coset. And if I operate A from the right side with all elements of H, I get right coset. Once my group G is abelian, this cosets will coincide. That is, left coset will be equal to right coset. We can see an example. Consider group G, which is set of all integers under addition, and a subgroup H, which is the multiples of 4. Take an element 0 from G and form the coset 0 plus H. This is obviously a left coset because 0 is operated from the left side. So 0 plus H will give me capital H itself, because 0 added to 0 is 0, 0 added to 4 is 4, 0 added to 8 is 8, etc. etc. So I am taking another element from G, that is 1, and I am adding with all elements of capital H. 1 added to 0 is 1, 1 added to 4 is 5, 1 added to 8 is 9, etc. etc. So this is the coset formed by using 1. When I take 2, the coset formed is 2 added to 0 is 2, 2 added to 4 is 6, 2 added to 8 is 10, etc. etc. If I take 3, then the coset formed is 3 added to 0 is 3, 3 added to 4 is 7, 3 added to 8 is 11, etc. etc. So these are some of the cosets of group G. Now I would like to ask a question. If I am taking an element A from G, which is also in capital H, is there any speciality for its cosets? Yes. If I take an element A which is both in G and H, the coset of A will be capital H itself. This is because of the closure property of subgroup. If I take an element A from H and operate with all elements of H, I will be getting the elements of capital H itself, because a binary operation is closed in capital H. Now we will see some more examples, some more properties of cosets. Before that, consider H as a subgroup of a finite group G. Consider H which is subgroup of a finite group G. Then I have two important properties. First one is order of the coset H will be equal to order of H. That is, if H is a subgroup having order 10, then the coset H will also be having the order 10 itself. Coming to the second property, if I am considering two cosets AH and BH, then these cosets will be either same or will be completely disjoint. You can see in the figure, either AH will be equal to BH or AH intersection BH will be empty. This is all about the cosets. In the next video, we will be discussing the Lagrange theorem. Thank you.